add and simplify if possible. We have here the sum of two rational expressions, and the first thing that I notice is that this denominator and that denominator are not the same. If we have the same denominators, we can add rational expressions by just adding the numerators, right? Putting it over the common denominator. This is the same way that works with numbers, right? If I have 1/2 and I have 7/2, I can add that by just adding the numerators, right? Um, Different denominators with numbers as well as with rational expressions, right, entails a bit more work. If I wanted to say add a half and a third, different denominators, I'd have to get a common denominator. So I could rewrite 1/3 by taking and multiplying 1/3 by 2 over 2 and multiplying 1/2 by 3 over 3, multiplying each by 1, right? And that changes this to a 3/6 plus 2/6. Right? And now I can add 2 and 3 is 5 all over 6. We're going to do the same sort of thing here. We're going to go ahead and get a common denominator. We're going to get that common denominator by multiplying by the correct version of 1, something divided by itself, where I pick this thing so that when I do this product, I get the same as I pick this thing so that when I do that product, I get the same as, well, the same as each other, right? So let's go ahead and do that. Um, uh, we could do a little bit of factoring first to help us out some. Um, we notice there's a multiple of 3 in both of those terms, so we could pull a 3 out. So let's do that. Pull a 3 out of 3y, we're left with y. Pull a 3 out of -6, we're left with a -2. Here on this second one, we have a 4 in both of those coefficients, so we can pull a 4 out. So we do that. So we get a y plus 2 times 4. So here are the prime factorizations of these two rational expressions, the two denominators of our rational expressions. So what I'd like to do is to go ahead and add in, well, multiply in rather, to this denominator the parts that belong in this other denominator that aren't already here. And in this case, it's all of them, right? There's a 4 over here, there's no 4 over there, so I'm going to have to multiply in a 4. There's a y plus 2 over here, there's no y plus 2 over here, so I have to multiply in a y plus 2, right? Of course, to do that, I got to multiply by the numerator, same thing as well, so that altogether I have a 4 over 4, I'm multiplying by 1. I have a y plus 2 over y plus 2, I'm multiplying by 1. So I'm not changing anything when I do these multiplications. I'm going to do the same thing to this other one, right? There was a 3 here, there's no 3 in the denominator here, so let's multiply 1 in. There's a y minus 2 here, there's no y minus 2 here, so let's multiply 1 in, all right? And same as we did over here, in order to multiply in a 3 in the denominator, I got to multiply in a 3 in the numerator. In order to multiply in a y minus 2 in the denominator, I got to multiply y minus 2 in the numerator. So now we have the same denominators. We have 3 times 4 times y plus 2 plus y minus 2. 3 times 4 times y plus 2 times y minus 2. Same denominators. So I can do this addition. 3 times 4 I'll write as 12. And then we have a y minus 2 and a y plus 2, which if you'd like, you could write that difference of squares, right? Y squared minus 4. But let's leave it in factored form because ultimately we'd like to simplify if possible. So after we've done some addition in the numerators, we'd like to see if there's a common factor to cancel. Denominator's already factored. Let's leave it that way because we're going to want it factored later, right? So 4 times 2, that's 8. I'll take and multiply 8 times y and 8 times 2, giving me an 8y plus 8 times 2 is 16. So that's what this first numerator looks like. Plus 3 times 3 is 9. 9 times y and 9 times a minus 2. So there's what we have. Let's go ahead and combine some like terms. I have an 8y and a 9y. That's a 17y. 16 minus 18, that's a -2. This is all over the same thing. At this point, I say, oh, the numerator doesn't factor any. I'm not going to have any common factors. If you'd like, you could go ahead and do that multiplication, y squared minus 4, difference of squares, or you could leave it in factored form. Whichever you feel like doing would be fine, right? So here's our final answer right there.